Welcome to Jasmine Tutor's VCE Chemistry Prep videos. In this video, check out our lead chemistry instructor go through an exam paper with one of our VCE students with crucial insights and tips to boost their score.
You got 10 minutes to do 6 for me.
Okay.
Okay. 10 minutes, huh?
Hmm?
You can see the question on my screen too, yeah?
Yeah, I've
Okay.
just got it in front of me.
Okay. And stop. Okay.
Okay.
All right. So let's take our data booklet out. Okay. Where did you find those two chiral?
I only found one. It was like
Yeah.
this one.
Okay. Yeah. So that's not the one. Can you take that out? I'll show you how to locate the chiral, yeah? The chiral ones are here, the ones near there's two chirals here.
Right. How do you know?
That's because you know those two lines that stick out? Yeah, can you see those two? They're
Yeah, like
showing
this?
isomers of some sort. Yeah,
Okay.
and the other one. So anytime there is an isomer of some sort, a stereoisomer, you'll be able to pick up the fact that there's chiral carbons is rotating around it.
Mm-hmm.
Okay, so that's how we pick that up.
Okay.
Okay. Number
Okay,
B,
nice.
what did you put?
I said a suitable solvent to extract catechin might be ethanol. Ethanol is polar due to the alcohol groups
Yes,
present,
yes,
as
yes.
is catechin, which contains many OH groups. As like dissolves like this solvent may be most suitable.
Yeah, the thing that you didn't tell me is catechin is a polar molecule.
I said that.
Oh, you said that. Okay. So if it's
Yeah.
a polar molecule, it would dissolve. So water or ethanol, they accepted both.
Okay.
Okay, good. You can take out that thing.
Sorry.
That's okay. Now, several forms of catechin effective. Explain. You must use a key terminology, a key terminal. What is it?
So I said for C, I said it may be possible that catechin enantiomers are
Yes.
unable to bind to the substrate due to differences in their structure.
Yeah.
And then I
Yeah.
said the catechin is supposed to act as a competitive enzyme inhibitor. However, differences in structural arrangement of atoms and bonding only means only one catechin may be effective.
Yeah. Okay. So too long, Ayazi, you won't have time.
Okay.
Okay. So let's cut it. Just say that they're enantiomers. They're two different enantiomers of each other.
Yeah.
Enantiomers have the capacity to act differently on the body.
Yep.
And they're because of their different spatial orientation of their functional groups, they bind to the enzyme sites differently.
Okay.
Okay,
Yeah.
so key points. Now I'm using enzyme sites, I'm using enantiomers, I'm using different spatial orientation, all the keywords.
Yeah.
Okay, just direct into the point.
Yes.
Okay, get what I mean?
Yeah.
Otherwise, it's too long.
And then D, I said a competitive enzyme inhibitor would counteract the possible negative effects of the mushroom by binding to the substrate before the catechin oxygenase can. And then I said, according to the lock and key model, the competitive enzyme inhibitor needs to have the functional groups necessary to combat the, and then I think I was gonna say the like the oxygenase, basically.
Yep. Key thing is it will block the enzyme active site. So you
Okay.
must use the word active site and the fact that
Okay.
it will block it. Okay. All right.
Mm-hmm.
Good job. Okay. 10 minutes, yeah. 9 minutes is 11 minutes, yeah. Okay, you start now. 5:45, 7:45 you stop, yeah. Hold on, let me check. All right, so the capric acid is found in coconut oil.
Mm-hmm.
All right. It does not have an iodine number. Why?
Because it has
Go back to your
I
data.
said because the molecule is unsaturated with no C double C's.
Yes, there's no double C bonds.
Okay.
Okay, that's why. Because there's no C double C bonds, it's
Yeah.
no need, okay? It won't have an iodide number, it won't break it. Okay?
And then can I draw it out onto the
Yes, draw it out for me.
Okay. Is that correct?
Okay, what is R? They told you very specifically what R is what.
Because I wasn't sure how to draw it. Like
Yep, okay.
it's just like
Yeah, so you're correct in that way, okay? And you're correct in there that it has a C double O bond. That's correct, yeah?
Yep.
Correct?
Yep.
But it's methanol.
Oh,
So
okay.
one of the chains must be CH3. That's the alcohol component. Then the other side is your fatty acid or your capric acid. Okay. So I go back to my thing and I check what's my capric acid look like. Oh, sorry. Let me go back. Hold on. What's my capric acid look like? You saw it here, right?
It's in the list of the
Yes, it is. Okay. So
just further
they're
past.
here. Capric acid C3, CH3, CH2, 8, this one, C10. Okay. All right. So I go back to here and I've got one, this one is one. Then I've got 9 others.
Okay.
Yeah.
Yeah.
All right. So I've got, yeah, and I've got 9 others here. So I will have C9, whatever.
Yeah.
Okay. Got it?
Yes.
Yeah. It has to be quite clear that you know that it was methanol.
Okay.
Okay. C.
And then
1, 2, 3, 4, and then you got 9, and then you got all the H's. Yeah.
yeah.
Okay. What about the lipase one? You're a bio student. You'll be
No,
good in all these questions.
no. Lipase has an optimum pH of that. I said that for the triglyceride to be effectively hydrolyzed, the conditions must be slightly basic with excess OH available, which reacts with the C double bond COOH and NH2 groups.
Yes.
Triglycerides may form water as a byproduct, which aids this digestion.
Yep. Okay. Where do we find lipase in your digestion system? Where do we find it?
In
Your
stomach?
intestines, your liver. Okay. So you need to make reference and you know where the digestion is happening.
Really?
Okay. Okay. So you know it's part of your curriculum, the digestion. Hydrolysis, all that. And the second thing they gave a mark for is that you must know that it will break the ester bond. Because lipase is an enzyme, it's also an amino acid, it's also a protein, okay, and it will break that ester bond.
Yeah.
That's what.
And then draw the Zwitterion. What does it mean by draw the Zwitterion?
Huh? Zwitterion, do you remember Zwitterion? It has both positive and negative.
Yeah,
Yeah.
but
So you're going to
it's
do,
like,
so go look for the aspartic thing in your data booklet.
mm-hmm.
Okay. And then if it's a Zwitteron, it will have both a neutral charge. It will have a positive and a negative.
Okay.
Know what I mean?
Yeah.
Yeah.
Okay.
Okay. So have you found that?
Yeah.
Okay.
So wouldn't it just add a H?
Yeah. Add a
all
H
the
to the
time?
NH
Yep,
and take
and then
away one from either carboxylic group.
yeah. Okay.
That's it.
Yeah. So just lose the double bond O, right?
Yes.
Okay. And then for the aspartic ion at pH 11, I just put the aspartic.
Yeah.
Why am I getting?
So the aspartic at 11, what happens when there's a pH of 11? When there's a pH of 11,
Very basic.
basic, yeah, basic. So there's going to be more OH in the solution. The H is going to join with the OH. So there will be two negative charges.
Okay. Yeah.
Okay,
Yeah.
got that one?
Mhm.
You want me to draw the structure out for you?
No, it's okay.
Okay, okay. All right. And then the last one of the ionic bonds.
I said the cysteine.
Yes, cysteine is good. In doubt, cysteine is a good one because it's got all the ionic charges there.
I did the C double bond O connects to the NH and it forms
Good.
an A
As
minus.
long as you can show that dipeptide bond, that's important. Good job.
Yeah.
Okay. Good job. All right. 13 minutes for the next one.
Okay.
Yep. So 13, 8:10, you finish. Okay. Stop at 8:10. One more minute
Okay.
and stop.
For the first one, I said the fruit or vegetable juice used as an aliquot.
Okay, hold on. What is the independent variable?
The fruit or vegetable
Fruit or veggie? Yes, the type of fruit. And your dependent variable is your?
vitamin C concentration.
Yes. Okay. And the two half equations, did you put it together?
Yeah, I put C6HAO6 aqueous.
Yeah.
C6H6O6 aqueous plus 2H plus.
Yeah.
And then I put
Oh, yeah, but you're short of 2 electrons.
oh, okay.
2H plus and 2 electrons.
Yeah.
Okay. And
And then I put I2 aqueous plus 2 electrons becomes 2I minus aqueous.
yeah, good job. Well done. Good. Well done. You got to get the iodine one from the data booklet. Okay.
Yeah.
Expected color change.
I said the color would change from red to blue as the reaction progresses. As the red pigment comes from the plant and is reacting with iodine.
Good job. It's red becoming blue, but red and blue it won't become blue. The blue color will pick up the red and it apparently looks brown. Okay.
Okay.
How you're supposed to know, I don't know. Okay. What do you think about the discussion of the student's conclusion?
I said the student's conclusion does not restate the aim or the results as a valid proof for their conclusion.
Exactly.
An
Good job.
aim should have been included as well as supporting evidence.
Yeah.
That was my first point. And then the second point, I said the student uses the first person, my, which is not scientific convention and
Yeah.
also erroneous.
Yes. Okay. So couple of things also to discuss with that is with the experiment. Can you see that in the experiment, you got to look at these things a bit closely, okay? This
Dilute the orange juice.
the orange juice came from a
saw that.
carton.
Yeah. But
Okay,
then
if it
everything
came from a
else.
carton, then how
Yeah.
do I know
And
That
also one thing is a powder and two things are blended, so you don't
Yeah.
really get the concentration.
the plum powder, all that also is not very stable because I mean it's not very consistent because there's other things that might have been added to it. Okay, like you
Iodine
know
also can have a shelf.
the vitamin C, you could also have antioxidants in it.
Yeah.
Okay. So and then orange juice has not been diluted, whereas all the others have been diluted to 100 milliliters.
Mhm. Yeah.
So yeah, so not sure what that was. Okay.
And also with the iodine, they said that they specified that it came from a previous year, but doesn't it degrade like fast?
Exactly. Iodine degrades very fast. That's a very good pickup.
Mhm.
Good pickup. So iodine might not have been at the best use.
Yeah.
Yeah, that's a good pickup.
And then I said for the last one, using lab equipment such as a volumetric flask would be helpful.
Yes,
And
correct.
then I said repeating the titration process 3 times and calculating a concordant titer.
Yes, that's correct. Yeah, both of them are reducibility correct. Good way, good job.
Okay.
Number 9, this is a long one. Okay, and then hold on, 1.25 times 12. 15 minutes, okay? And then we're done. 8:29, and then I'll go through it with you. Okay,
Yeah.
last question. Okay, we can stop now.
Yeah.
Okay,
I didn't really finish, but I can tell you where I was going.
okay, good. An understanding of the unit use in viscosity. Okay, all right, let's go.
I just said for the definition, my first stop point, I said viscosity refers to the rate at which the mixture flows at a certain temperature.
No, viscosity is the resistance of a flow to a liquid.
Okay.
Okay,
So resistance of a flow.
so it's the resistance to flow of a liquid.
Okay.
Okay, yeah,
And then I said in a homologous series, the longer the molecule, the more viscous it will be due
yes,
to the length of its carbon chain. The
yeah,
properties include this viscosity increasing as the inability to flow would at SLC. And then in the ethanoic acid and octanoic acid, this is
yeah,
shown through their values of that.
yeah. Yep. So the you have to say the viscosity increases with molecular size.
Yeah.
You have to tell me that there's dipole between the O and the H
Yeah.
for ethanoic and so ethanoic is polar. Okay.
Yeah.
Ethanoic is polar. No, yep, this is polar.
Yeah.
This is polar
Mhm.
and this is non-polar.
Okay, so you need to refer to the polarity.
Yep, so you need to refer to the polarity. Okay, negative and positive, they're dipole-dipole bonds that form. Same with the OH.
Yeah.
Okay.
Yeah.
So you need to be able to, all right. Okay, it's higher than ethanoic acid. Viscosity is higher. There's more resistance to flow than this because ethanoic acid also has a shorter carbon chain.
Yeah.
Whereas the carbon chain in an octanoic acid has got 8 carbons, so longer. So viscosity increases according to the increase in the molecular size.
Yeah.
Okay. There's also hydrogen bonds that exist in polar, which are very hard to break.
Yeah.
Whereas this is octane is carbon. There's very weak dispersion forces. These weak dispersion forces allow it to kind of slide over each other.
Okay.
That's it.
Yeah. Weak dispersion forces. That's a lot for one answer.
Yeah, 5 marks. You define viscosity. You
Mm.
talk about each molecule. Octane is a hydrocarbon. The forces in that is very weak. So it's got the lowest viscosity, whereas the other two guys have got autonoic acid is carboxylic and 2 oxygen, so presents more dipole and harder.
Okay.
Okay, and then molecular size. All that will give you about 5 marks.
Yeah.
Okay, that's basically it.
Thanks for watching this exam prep with our chemistry tutor from Jasmine Tutors. Hope it was helpful. Check out jasminetutors.com for more info or reach out on 0493 288624 or by email at info@jasminetutors.com.